Hello students, welcome to Code to Serve Academy. Today we will deal with factorization chapter in which we will learn about polynomial. So what is a polynomial? Any algebraic expression which is of the form e naught x to the power n plus e1 x to the power n minus 1 plus e2 x to the power n minus 2 plus dot dot dot, in which the degree of x are continuously reducing itself and going up to x to the power 0. Okay, so the expression which is of the form e naught x to the power n plus e1 x to the power n minus 1 plus e2 x to the power n minus 2 continuously moving towards a n minus 1 x plus an is said to be a polynomial of nth degree if this e naught is not equal to 0. So why we are seeing this e naught as not equal to 0? Why this e naught should not be 0? So if we take a naught as 0, this polynomial equation will be of n minus 1 degree, because here when e naught is equal to 0, this whole term will be 0. Okay, this whole term will be 0. So when this whole term will be 0, then the leading coefficient will be e1 and the degree of x will be n minus 1. So this whole polynomial will be of n minus 1 degree. That is why we are saying that E naught should not be 0. Okay. Whenever this expression is equated with 0, that type of equation is termed as polynomial equation. Here also, this A naught should not be equal to 0. Now, as we have said, to make it a polynomial equation, we have to equate it with 0. This expression should be equated it with 0. So how can we make this equation, how can we make this polynomial equal to 0? So to do it, we can do two type of things. First thing is to make this x is equal to 0. So what happens when we take this x is equal to 0? When we take this x is equal to 0, this term e naught x to the power n, this term goes to 0, this term becomes 0, and continuously all the terms up to an minus 1x, in which x term is given, becomes 0. But this last term, that is an x to the power 0, doesn't become 0 because x to the power 0 is 1. So this whole fx becomes equal to an, which is not equal to 0. This whole fx becomes an, which is not equal to 0. Okay, so that is why we cannot make this polynomial is equal to 0 by taking x is equal to 0. Okay, so what can we do? We can take this e naught is equal to 0. When we take this e naught is equal to 0, this term will be 0. Similarly, when we take e1 is equal to 0, this term will be 0. If we take all the ai's as 0, then this equation, then this polynomial will completely be 0. So to make this polynomial equated with 0, to make this polynomial a polynomial equation, we have to make all these ai equal to 0. We have to make all these ai equal to 0. So whenever we take x is equal to 0, then whatever we get fx is equal to an. An is what? An is a type of constant. An is a coefficient. Coefficient is a type of constant in which the degree of x is 0. Whenever we get fx is equal to a type of thing in which x degree of x is 0, we say that fx as 0 degree polynomial. But we say this fx as 0 degree polynomial. And whenever all the ai's are 0, then we say that polynomial as 0 polynomial. So this polynomial in which all I is 0, all ai is 0 are termed as 0 polynomial. And These type of polynomials are represented by the symbol 0 or O. Okay. Now, it is very much important to understand the difference between zero polynomial and zero degree polynomial. So in zero polynomial, all the terms are zero. But in zero degree polynomial, there exists one term which is the last term, which is an x to the power zero. Since the power of x is zero, hence we say them as zero degree polynomial. It is of the type fx is equal to c. So fx is equal to c type of polynomial are termed as zero degree polynomial. Okay. Now we will move towards equality of polynomials. When can we say two polynomials are equal? Let us suppose that there are two polynomials. The first one is of 4 degree and the second one is of 3 degree. So can we say these two polynomials are equal? Can we say it? So to understand this, what we have to do, we have to understand the basics. Two people are said to be equal if they possess same properties. Okay, if they possess same properties. So we can say these two polynomials, that is, let us suppose that our fx is of is of the type a naught x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 continued up to an. And our another polynomial, that is gx, is of the type b naught x to the power m plus b1 x to the power m minus 1 plus b2 x to the power m minus 2 continued up to bm. So these are two polynomials. We are not known what is the degree of fx and what is the degree of g. So to make them equal, what we have to do? First of all, we have to make their degree equal. Okay. When the degree will be equal, then we can say that both the polynomials will go up to same number of terms. Okay. And we have to make these coefficients also equal. Okay. So what we have to do to make two polynomials equal, we have to make the degree of the two polynomials equal, that is n is equal to m. And the next part which we have to do is we have to equate these coefficients. This a naught will be equal to p naught. This a1 will be equal to p1. This a2 will be equal to p2, and similarly the next terms will be. Okay. Now, division algorithm for polynomials. We know that as according to the division algorithm given by Euclid, we know that dividend is equal to divisor into quotient plus remainder. Dividend is equal to divisor into quotient plus remainder. So if we take fx as our dividend, let us suppose for real numbers or for integers, let us suppose we are getting 8 divided by 2. So what we get on multiplying with 4, we get the remainder as 0. We get the remainder as 0. So this 8 is dividend. This is divisor. This is quotient. And this is our remainder. So by using this concept for polynomials, whenever we are given a polynomial fx of n degree and our divisor is given gx of some degree, whenever gx is trying to divide fx, we will get a unique quotient qx and a unique remainder rx. Both are in the form of polynomials. That is why we are writing qx and rx. They may be in the multiples of x, that is x to the power 0, x to the power 1, x to the power 2, x to the power 3. That is, they can be of quadratic form, they can be of cubic form, they can be of quartic form, okay, biquadratic form. So that is why we are using here as x for the reference, that all these are polynomials, not numbers. Okay. So we have to note it that fx will be equal to gx into qx plus rx. Fx will be equal to gx into qx plus rx. Now, what is the condition for rx? As we know, for Euclid division algorithm, we know that the remainder will be always equal to 0 or greater than 0 and less than the divisor. Okay, but here what happens? The remainder function is equal to 0, maybe the remainder will be 0, or the degree of Rx will be less than the degree of Gx. Because if we are getting, let us suppose that we are getting the remainder as x plus 1. We are getting the remainder as x plus 1. How can we say that this remainder is positive or negative? So we can only say about the degree of this remainder. That is why what we are saying that either the remainder function will be 0 or the remainder function, the degree of this remainder function will be less than the degree of g. We will learn it later that when the degree will be 0 and when the degree of Rx will be less than degree of Gx by some examples. Okay. So if we are getting Rx is equal to some constant, if we are getting Rx is equal to a to the power n form or coefficient form, then what happens? This Rx will be equal to some number that is 14. Let us suppose that Rx is equal to 14. Let us suppose that we get Rx is equal to minus 14. So what we are that our Rx, that is our polynomial function of remainder, is here negative also. But in case of integers, what we see, remainders never be negative. Only formal remainders are taken. Only formal remainders are taken. So in this case, a violation is seen. But if this is the case of polynomials, so we can say that the remainder can be negative. The remainders can be negative. Okay. Now, let us see when our Rx will be 0, when our remainder function will be 0. So, if let us suppose that we are given fx, which is a cubic polynomial, in which the degree of x is 3. So, this is suppose this is our cubic polynomial 2x cube plus 3x square minus 3x minus 2, and we are set to divide it with the divisor function gx, which is equal to a linear function x plus 2. So we have to divide this 2x cube plus 3x square minus 3x minus 2 with x plus 2. So how can we do so? We all know to divide this. In class 8, we have learned to divide polynomials with linear polynomials. Okay. So let us do it. For to get 2x cube, what we have to do? We have to multiply this x with 2x square. So we have to multiply this x with 2x square. So when we multiply this x with 2x square, we will get 2x cube. Okay. Now here plus 2 is also given. So this plus 2 will be multiplied with 2x square. So it will be plus into plus is plus. 2 into 2 is 4 x square. Okay. After subtracting these two, what we will get? This 2x cube and 2x cube will be cancelled and we will get minus x square here. Here there are two terms. If this x is multiplied with minus x, what we will get? X into minus x will be minus x square. So what we will do? This is minus x square and here the second term is plus 2. So plus 2 when multiplied with minus x, it will be minus 2x. So we will require a term which contains a term which is of power 1, in which the degree of x will be of 1. So we will require this also minus 3x also. So let us suppose that we have taken this minus 3x also. So whenever we multiply this x with minus x, what we will get? We will get minus x square, and plus 2 when multiplied with minus x, we will get minus 2x. Okay. On subtracting, what we will get? This x square and x square will be 0 and we will get minus x here. We will get minus x. This is x and this is minus x. When can we get minus x? By multiplying minus 1. By multiplying minus 1. So on multiplying minus 1, this minus x is done. But this plus 2 should be multiplied with minus 1 and we will get minus 2. So to subtract minus 2, we are requiring some constant. So here is the constant. We have to take it. We have to take the left part. So whenever we multiply this with minus 1, what we will get? X when multiplied with minus 1, it will be minus x. And this plus 2 will be multiplied with minus 1, we will get minus 2. On subtracting, this x minus x will be 0, this 2 minus 2 will be 0, and we will get remainder as 0. We will get remainder as 0. Now, whenever the remainder is 0, what happens? This x is completely dividing this fx. Whenever this remainder is 0, this x is completely dividing this fx on multiplying with this quotient. Okay, so what we see, whenever rx is equal to is 0, then gx will completely divide fx. Okay, and when gx will completely divide fx, what it means? It means that gx is a factor of fx. Then we can say whenever the remainder will be 0, we will say that our gx, this gx will be our factor of fx. Okay, so this is to note down. It is very important to understand which is our factor and which is not our factor. Okay, now this was for the case when we are getting 0 as the remainder. The remainder is 0. But what about the degree part? We have said that degree of Rx should be always less than degree of Gx. We have said that degree of Rx should be always less than degree of Gx. So let us assume some examples on the basis of which we can say that this is always true. Okay. So let us suppose that our fx is a fourth degree polynomial. Whenever it is a fourth degree polynomial, it is said to be a biquadratic polynomial or a quadratic polynomial. Okay, you remember the names. Whenever a polynomial is of fourth degree, we say them as biquadratic polynomial or a quadratic polynomial. And let us suppose that our gx, that is the divisor, is a second degree polynomial. It is a second degree polynomial. A second degree polynomial, we all know, it is a quadratic polynomial. So whenever a quadratic polynomial divides any polynomial which is either biquadratic or pentaic polynomial, or any polynomial of nth degree, what we will get on dividing, whenever we try to divide these two, what we got some remainder. Since this is a complex calculation, hence I am not showing it to you. You try it in your home and let me know if you are facing any issues. I will help you. Okay. So what I have got this as the remainder. So our divisor, that is Gx, was of second degree, and what we got, our remainder is of first degree. Our remainder is of first degree. So what we see that whenever Gx is dividing fx, then Rx is a degree of Rx, that is the degree of remainder is always less than the degree of Gx. That means the degree of the divisor. Okay. So this was the first example through which we can say that degree of Rx is always less than degree of Gx. Let us move towards our second example. Let us suppose that our fx is 2x cube minus 7x square plus 5x minus 9. That is a cubic polynomial. We can take fx as any polynomial of any degree. Okay, it is not required to take this polynomial only. Okay, we can take any polynomial, but the condition is that we have to fix our gx, whether it is linear polynomial, whether it is quadratic polynomial, whether it is cubic polynomial or any polynomial, on the basis of which we will get the degree of Rx will be always less than degree of Gx. Okay. So for this case, we have taken fx as 2x cube minus 7x square plus 5x minus 9. When dividing with Gx as 2x minus 3, what we get as the remainder we will see. Okay. So this 2x when multiplied with x square will give 2x cube. Okay. So this 2x when multiplying with x square, it will give 2x cube. And this minus 3 when multiplied with x square, it will give minus 3x square. Minus 3x square. On solving, on subtracting, what we will get? We will get this 2x cube minus 2x cube will be 0. This minus 7x square plus 3x square will be minus 4x square. Since the divisor is of two terms, so we have to take one more term, that is plus 5x of the another term which is of one lowest degree to that term. Okay. Now, to find out this minus 4x square, we have to multiply this 2x with minus 2 of x. So this 2x multiplied with minus 2x will give minus 4x square. And minus 3 when multiplied with minus 2x will give 6x. Okay. On subtracting, what we will get? This 4x square and 4x square will be cancelled. And here it will be minus x. So what we got? Minus x. And the remaining part is minus 9. So we have got minus x minus 9. Now, what we will do to make this 2x as minus x, we have to multiply it with minus half. Minus half when multiplied with 2x will give minus x. So it will be minus x. And this minus 3 when multiplied with minus half, it will give 3 by 2. What it will give? 3 by 2. On subtracting, what we will get? This x and x will be cancelled. And minus 3 by 2 minus 9. What we are getting? Minus 3 by 2 minus 9. That means minus 3 minus 18 by 2. That means minus 21 by 2. So we are getting minus 21 by 2 as the remainder. This remainder is of the form fx is equal to c. We know that fx is equal to c or rx is equal to c can be written as Rx is equal to Cx to the power 0. So it is a 0 degree polynomial. We have taken 2x minus 3, that is a linear polynomial, as the divisor, and we are getting the remainder as a 0 degree polynomial, in which through this we can say that degree of Rx should always be less than degree of Gx. Okay. Now, one more thing to understand is we have to recap all the things what we have learned. We have learned that any polynomial is of the form a naught x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus dot 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 up to continued up to so on up to an, where a naught is not equal to 0. We have learned that any polynomial which is in the form of fx is equal to c is said to be a 0 degree polynomial. We have learned that if in a polynomial all the coefficients are 0, then we say that that polynomial will be equated to 0 and are said to be a 0 polynomial. Okay. We have learned that two polynomials are equal if all the coefficients of that two polynomials are equal and the degree of that two polynomials are equal. Okay. And what we have learned here, that the evident, that is our function fx, that is our any polynomial, when divided with any polynomial gx, that is non-zero polynomial, we get unique quotient and unique remainder function, okay, in which the degree of Rx is less than degree of gx and rx may be 0. So there are two cases which we have seen, that rx should be 0 or degree of rx is less than degree of gx. Till now we have learned all this, and after this we will do the question part. Thank you.